Great. Well, thank you again, and let's give the floor to Antoine.
Okay, let's get started then. I think I'm going to share my screen. I guess the best is to start with the installation, and in the same time when we're normally here you can see my screen now. So I don't know if you guys already tried to run the script, the installation script. This is here. So for the one that are on Linux, it's quite straightforward. There is nothing to do apart from having a Docker and making it available to run with a non-root user. So yeah, if you already had issues with that, can gladly help. Otherwise, we can get started with saving the files. The reason why Bodo said that it was good to start it already is because it takes some time to pull the images. They are like some gigas. So once we are here, we can mod the script so that we can. So here it's not working because we need to add install plus the version we want. Since I think from what I saw, or at least one of the projects is using V2E, that is with Python 3.8, as well as Nengoloi is also working with Python 3.5, I think. And so the best is here to install the latest version, meaning that it's suppose you're running on Ubuntu 20. Yeah. If you're not, the best would be to use a sh root. Yeah, there are some workarounds which we can have a look at. So for me, it's pulling really fast because I already have it. Needs to be stopped because I had it installed. So I stop it. It's starting again. Then what is going to take a bit of time is to clone the models, since my internet connection is not the greatest. So unless you guys already have some question, otherwise I'm going to try to give you a feeling of what is and what is not the NRP, the Neurorobotic platforms.
Sorry, before you go there, can I have a show of hands, maybe in the chat, who's been able to install it already? Okay, so I'm at the point of running this script here, and it tells me that docx wasn't found, but maybe that's because I'm on Windows with the
okay.
WSL.
Yeah. So yeah, with Windows, there are some pre-step to do first. The first one is to have a Windows Linux subsystem installed, so that you have. You also have the Docker installed.
Yes.
From not within the.
No, in Windows. Yeah.
Okay. Yeah. Okay. So that's good. And then open a Linux. And did you start the script in the Linux terminal and not in the Docker? Or
Yes.
from anywhere else?
I started from the Linux terminal. Yeah.
Okay.
I think I'm. Okay, I probably know what the issue is. I think I need to register my user in the right group.
Okay, yeah. So in order to be able to pull the idea is to try to connect physics simulators. In our case, it's Gazebo with the rest of the world. So in the first thing that was connected to it was a brain simulation nest. So it was possible to load a network, usually of small sizes, and to connect them through those transfer functions that are communicating between the two. But it's also possible to try and connect other brain simulation first, so such as Nengo, that's already been done, and Nengoloi is on his way to production. So Manos Angelidis is going to talk a bit more about this. Otherwise, it's also possible to try and connect other kind of code with Python, TensorFlow or PyTorch, or other Python code such as I don't know a DVS emulator. In that case, we would be working on that part, creating a Gazebo plugin. So it means that there are going to be necessarily interaction with the C++ code at some point. But there is a tool for that is called IBA to facilitate the connection between Python and C++. Then on the backend side, this is using rendering. So what we are going to be able to look at the simulation, and the models are in a repository that.
Is this document available somewhere?
Yeah, this is from the documentation, so I can share it. So yeah, the core of the NRP is the CLE closed loop engine that is doing the connection between the components, the controller that is controlling the robot through the communication is done with ROS, and also controlling the transfer function. It's working in a cycle of 20 milliseconds. So in between, communication is done asynchronously, but there is always this synchronization every 20 milliseconds to make the moves and the updates. So maybe what I can do already, because I already have the image, is to show a way to connect to your. Here I have visual code, but there could be other ways. I'm going to show with Visual Code, Visual Studio Code. Then you can code, directly access the code instead of just using the front end. If you guys need to do some more advanced stuff, so to do that, we need to add the plugin, the Docker plugin here, now already installed, and then we can in this we can access the two containers. The first one is the backend, and the second one is the front end. So here you guys are going to be wanting to look at the backend one. We can also open it directly in its own window. Then we are from within the container. It just takes a little time for starting the server on the inside from within the container. So then when we're here, what important thing is this up, because it contains the storage. So that's where the experiments are going to be located. Here for now, we don't have any experiment. We just have the user data, the database access. Then inside the NRP, we have the source code that encapsulate quite some repositories. The interesting one for us is going to be these Gazebo Rust packages. This is what I was talking about before, where we have the possibility to add some plugins that allows us to do some more sophisticated or things that are not directly available inside the NRP. And for example, we have here the IBM manager that is running so synchronously with the CLE, so with the core of the NRP, and that allows to run scripts that are external. So the IBM manager can manage different kind of modules that are then.
Does that mean our V2E, for instance, would go in there, or?
Yeah, that would be a good idea. So basically, I mean, from my point of view, the best way to do it is to use this IBM manager, and then to have a module here. So either using the already existing module, then we don't have to rebuild the C++ code, and then from here we have those modules where we can add some external code here. So import packages, and then run some code here. So there are two basic functions. The first one is to share module data. The second one is to run step. So the share module data is going to be more in between two steps, where we want to pass data from the robot to the brain or to somewhere else, so for example to the camera. And then the run step, where we are doing actually, for example, for the camera, is going to be the rendering of the image from RGB to the DVS. And then here are three modules. It's possible to have only one. Now it's going to be, yeah. So now it's generating the texture. I think that was also something that you guys were interesting about.
Yep, that's right.
And then it's gonna be starting the front end, and we can be starting really.
Is this firing up a particular virtual environment now, or is this still part of the installation?
Yeah, that's a good question. So yeah, from within the container to add some packages, we're gonna need to. Actually, I can already do that. Show how to get to the virtual environment if we want to add some packages. So NRP is the backend. So this is here. So opt, that's where there was a storage, is also the virtual environment that we can activate. And then from there we can add the packages that we need. I don't know. Is there a name for this V2E? Is it a pip?
Just try V2E, but Yuhang is here. You can.
Yeah, actually, it's not. I'm sorry. Actually, it's not on the pip, so you need to sort of manually install it.
But would TensorFlow work or something else here?
It's on PyTorch.
No, I mean, Antoine, if we want to just add some external package, could we try PyTorch or something? Or
we can try Torch, yeah.
Let me actually send you all the dependencies through the chat.
Okay.
Which I
was looking into it, and what I found as something that's going to be complicated is because it's using Conda. I mean, I guess it's not. It's just.
No, it's okay because because we can actually so the quanta is just to make it like a reproducible command. Yeah, you can use this. You clone it. Yeah, or exactly. You can pip install directly from the Git.
Yeah. Okay.
Yeah. But it looks like this Torch installation is killing you.
Despite Torch, yeah, you know my internet.
Yeah.
But I have to do something. Yeah. Yeah. Proceed. Yeah.
Yeah, but on that note, so Actually, if you're integrated with ROS, that will be very simple. That actually will be very simple for V2E to be integrated. You just have to be in your module to create an emulator object. And for every simulation step, when you have a sensor reading in, like a frame in there, and then you can say emulates to create events, and then this event will be returned as a NumPy array and use the raw spec message to send out.
Yeah, exactly. Yeah, you got the idea completely.
Yeah.
So let's have some visual now. I'm gonna start the. I think it must be here. Okay, so now this is a front end. I access from this IP. It's possible that localhost is also working for you. It's because I have already something on localhost, so I'm using this IP. But there we can access already quite some templates that we're not going to be running, but that are interesting. And then what I'm going to be sharing with you guys is this experiment that Hugo Albanese prepared for the workshop. And I guess this I can only share on Slack, or at least it can be easier. So I'm sharing it on Slack, and then I'm going to import it myself.
So is this ready to use already now, the maze environment?
Yeah, it's so it's working. It's not working with a DVS camera. It's working with a normal camera.
Yeah.
But we can have a look at it.
Perfect. And this is available already as the Docker here publicly. Okay, great. Really nice.
Yeah. First, yeah, we're gonna have to just do. There are 2 quick fixes to make it work. So they're gonna be quite important. So for applying those fixes, we're gonna be needing. This is still downloading, so I'm gonna access a second one, but we're gonna need to access our container. And then there are those two fixes that are important to make the. So this I can share in the chat. Oh, I had it already. So from within the container, they have to be run. So they fix some. So yeah, we need to update Gazebo from 7 to 11 in one side for the texture, and then for the other is for the build. There was a little mistakes, and since you are likely to need to build this Gazebo's package when you create a plugin, then this needs to be done. So I'm going to do it too. We did both. Okay.
I'll paste these commands in a Google Doc because they will be gone once we close the Zoom session.
I put them also in the chat, but if you want, I can.
Yeah, I'll document it.
Okay, cool. Okay, now should be ready.
Actually, Antoine, if you could paste them, because Zoom for some reason doesn't let me copy out of the chat. I don't know if it's just me or this.
Okay, I pasted them in the Slack thread.
I think you I didn't see what you pasted before, Antoine.
It's in the Zoom chat, but for some reason I cannot copy paste out of there.
Yeah, neither can I. So.
Yeah, they're in the Slack under your own comment.
Oh, great.
There's a reply.
Okay, awesome.
And yeah, so here it didn't work the first time for some unknown reason, and should be working second time. Yeah, sometimes the NLP needs to be.
So once you have a minute, there's a question in the chat.
Yeah.
Peter, for you.
Okay, yeah. So does the question refer to? Yeah, okay. We can integrate other robot models in the NLP. The idea is the best is to encapsulate it in in an experiment. The best is to encapsulate it in an experiment. We have quite some models that are robot models that are already available, but it's possible to add other models. If you are talking about using another physics simulator, then this is more complicated. So here I'm having some troubles because of timeout. So that's because of my computer, and this should be also an issue. So I need to wait a little for this to finish, because yeah, my computer is timing out on this.
Sorry, can you show again how do you get this maze experiment running, like the template for it?
So the template is in the Slack. This Telluride key, and then it needs to be imported with import zip from here. Once it's downloaded from the Slack channel to the reply of the tutorial. These answers. And yeah, for the robot, if it's just the robot model, then yeah, we can add them in the models. So it's going to be located either you have an experiment, you build an whole experiment, and then you add it to the storage here. Either if you only want to add the model, then you would have to add it in there. There are already quite some models. The best is to try and reproduce the organization of them. This is not a good example. Skip model. So usually they have the meshes, directory that called meshes, where we're going to have the DAE, and then they also have a SDF and a config. I think that's the three important files to make a model work. And then we have to create the symlinks from the model. Okay.
Sorry, I may have missed it, but this particular part is for the robot model that Peter was asking about, or is this for the environment?
This is for the robot model that was asking about, to try and add another model.
All right, thanks.
I'm gonna need to make some space, so I'm gonna stop the video, for example. Okay. No. quit everything. Should work. Okay, let's try again. Still not making it up. Can one of you guys make the experiment start from the front end?
Yeah, I did.
You did, huh?
Mm-hmm.
Okay. I don't get it. Okay, maybe we can follow on your screen if that's not a matter for you.
Then you're gonna have to give me a second because I made a different computer.
Yeah. Yeah. Okay.
Yeah. Let me check if I have.
Oh, then it's all right. What can I do to make this work? I could stop sharing my screen for a second. Okay. Okay. So here the experiment. So we can try navigate. So there is a maze. The idea is the robot has to go through the maze, and for that he's following the screens. But actually he's following the red color on the screens, and the screen change their. I can already start. Change their color automatically when the robot is in a certain position. So when it's starting, it's going to change the first screen to red. It's going to have a hard time because you guys know. So for on a normal computer or someone not sharing is faster. But this look like that. So this is going to go to red. And then once it's red, the Husky, how he's working, that he has a camera on top of it that is going straight. We can actually look at what he's seeing in his camera. It's going to give us an idea. And then once he's seeing the red, he's following it. Because he has two sensor neurons that detect the color, 2 or 3 actually, and then there is an inside, so it's all in nest, the neural network, and it has a layer, an inside layer with I think 5 neurons, and then output layer with 2 motor neurons. So the 2 motor neurons say going left or going right. So in the case where he doesn't see the color, he's just going, I think, right all the time. So he's turning on himself to try and see the color. And once he's seeing the color, then he's gonna go forward, and he's recognizing the so that's how it looks like.
Really cool, nice. So you put this together just for the workshop in the last couple of days, I understand.
Yeah, that's Ugo. He did a great job. It was based on I think a competition that happened where it was a maze also, but not exactly the same kind with with other requirement and then he took this experiment and tried to do something that could be useful for you guys. So there are a lot of possibilities here for you to, for example, change what's seen on the screen, and also to try and change the camera, the way it's working within the NRP. As Bodo said, there is possibility to do that already, to convert, but from what I saw today, it's just differentiation of images. That's already a first step, but I think the algorithm is a bit more.
So could you at some point show us where we would go in the code to, for instance, change what the screens are presenting here?
Yeah.
Or,
Okay. Or maybe I'm gonna.
Also, the kind of visualizations that you can do with this nice interface here. Can you also like show the network or something, or the network activities?
Yes, there is this. I don't think he had the time to make it. Yeah, there is this possibility. But when I tested today, he was not working on this particular experiment because I think he didn't connect them. But there is in theory the possibility. We could look at a complaint. It's called the brain visualizer, and from there it's possible to change the contrast of the spike and to see them spike in. But that I can show maybe after. Let's focus first on what's Bodo was talking about, which is changing the color of the screens and stuff like that. That is done through this state machine editor. So the idea is to control the environment. This state machine editor can be changed directly from here, and it has. So for start, there is 3 there are different states that are valid, invalid, and preempted. So it's when the conditions are met, and those conditions are the condition and the position of the USKI robot. So when he's getting into a certain area, we have to switch one screen from red to blue and one other screen from blue to red, unless we are at the extremes. And those conditions are showed here, are the hotspots. And then what we do is that we create those states of the state machine. The first one is the initial one, so it's going to wait for 5 seconds, then it's going to do the transition. So after 5 seconds, it's going to do this, and what he is doing is that is changing the color of the screen from there. So it's with a for loop. We set the first to red, for example, and we have a control over this is red is what we put. So we can put the color, or we can put a picture, for example. That's what is in the end. When we arrive at the end here, we're going to change with a logo, I think, somewhere. Yeah, that's here. And here we could think about changing with other also.
And it's the Telluride logo, I think.
That's the Telluride logo, exactly.
Cool.
And I think he put also some resources because he thought that you guys would be interested in maybe looking, so it's in texture, to look at the numbers. I think it's from the NMNIST data set.
Yeah.
And here it would be possible, for example, already to change from here with the help of the resources. So to see it logo, and and just call the right image and change it to a number, or you can also add your own image here and then change it. So that's one example. So it's working with with this callback function that is gonna. So it has a state. It's arrived to the state, and then when it finishes, it's using the callback to put a message if there is one, and then to stop the state. So that's for the state machine.
And could you show us network, how it's implemented, if you wanted to change that?
Let's close some things. So here it's it's implemented in Nest. So there are the populations sensor. So that's not what go on sensor parameters. Okay.
I see. So it's in Nest. Okay. Because so if you say wanted to insert a PyTorch or TensorFlow
so
model
directly in the brain editor, that wouldn't work. If you want to use an NGO is also supported. We have to change the brain adapter. But if you want to add some PyTorch, that would be also with the module that I was showing within the IBA here.
Right.
So that would be with I closed the. And otherwise, the third thing that is interesting is the transfer functions. That is can be, because this in theory is a possibility also to add your own code, but this is not recommended because when it's too heavy, then it's messing with the synchronization of the NLP. But for example, here there is two transfer functions that are used. The first one is to communicate with the robot, so to tell him what to do, either to go straight, either to turn around himself, using those alias. So it's Python, and then it's in 3D, so there are some kind of little calculation. So little calculation are possible in transfer function. More complicated one that's also use training, for example, is not something that can be. I mean, that has been tried, but that was not successful. And then here we have the sensor. So on the sensor side, with the camera that is added here. So when you want to communicate with the camera, that's something that you're going to be doing here. In your case, it's going to be good to use to create your own topic, your own ROS topic that is going to communicate through the Gazebo ROS package to the robot. And here what he's doing is that he's just taking the images, and then the brain is doing the little neural network is doing the calculation to know from what I'm seeing what I'm doing.
So Fabrice said something about version incompatibility with PyTorch and the workaround via ROS nodes. Can you tell us something about that, or is this not relevant anymore?
So yeah, that's I think that what we were a bit saying a bit earlier is that if we from the brain, yeah, there is this incompatibilities using the brain editor to use PyTorch directly in there.
Okay.
But where the workaround is to use this Casable ROS package. So I'm gonna explore, I think, one more time the 22 remote. Okay, let's open the folder to show you the interesting places in the NRP. So first, what you are talking about is this workaround using the IBA. There are some tries of doing it, so that's something that is also in progress in the team to do TensorFlow. There is an example of a TensorFlow experiment. Okay. No, that was not that. Why isn't it Casable ROS packages? Okay. It didn't load everything here. It's a bit weird. It didn't load everything. Okay. What I wanted to show is that now the experiment is here. So if you guys don't want to change in the front end, you can change things from here. There is this X, so that is controlling what's happening. For example, telling what is the state machine, where is the model, the transfer function are in the BB file. So to add one or to change, so it's important to have the right names, etc. Here, there are also the brain model here, but if you don't want to use Nest or Nango, then that's not going to be the place. And the transfer functions are here. And within this experiment, they're going to be the model, the robot model. What Peter was talking about. Here's a robot model. Okay, now let's try and access this Casable ROS package. Doesn't want to. Let's do it another way then.
So, Antoine, it would be really great if you could just paste those 2 or 3 paths that will likely have to touch somewhere. It doesn't have to be now, but at some point, so we don't forget it.
Yeah. So that's in the source code, and here is the way to add some PyTorch code is here, and then from the scripts to add it in the modules directly, and then they're gonna be in relation with the IBM manager. That's gonna do the synchronization with the simulation environment. So that's a workaround that was mentioned by Fabrice.
Yeah, and you said there's already one example using TensorFlow.
Yeah, there is an example of an experiment.
Cool.
I think this is not exactly the use case, but it should be inside the experiments. Here, maybe that's it. Doesn't seem to be ready. Yeah, they're doing it through the transfer function in that case. So there's two possibilities of workaround, either within the transfer function or within the IBA. And this was they're using the first way to do it. And then, yeah, it adds me to another thing then, because if you want to access other templates, the template experiment that are ready for production are good for visualization, but otherwise there are just I'm not sure, yeah, those dev that's gonna give you lots more templates, but that are in a stage where they are not ready for production, so they can be buggy, but I think then it's possible to access the TensorFlow from there and try it out, see what, yeah, there are some tries to make it work. So I know that they are not ready yet, so but it can be good to have a look at it. Otherwise, are there other question or something that arised?
Yeah, one question. How did you connect your VS Code to the Docker as a remote?
Yeah. Okay.
So I didn't see you do that.
Can do it again. Up. So the first thing is to add the extension, Docker extension that you have. Okay. Then you can see normally the container here. And I think it's not so nice to use it from here. You can open files one by one, but one thing is to click here and to do attach Visual Studio Code, and then you have it in a...
It isn't there with me.
It's not there. Oh
no.
Okay,
I'll look into that.
Okay, because otherwise from here I think it's also possible to open the thing. Where is it going to be? It's going to be in home. Here is going to be the NRP, otherwise, without attaching.
Okay, yeah, I'll just look this up. I think maybe I need some other thing to install.
Okay, and there is something in the chat, the remote container extension. Otherwise, there are two last things that I wanted that are quite important from within the container that can help to debug things sometimes. The first one is how to look at the log.
Just one note here. We should get ready to move over to the main session in 2 to 3 minutes. So if that's possible.
That's going to be
okay.
Good. But yeah.
I also want to ask, like, how we can get this visual environment that you have set up for Telluride, because I do not have that file.
It's in the Slack channel. As a reply to an earlier message from me, you'll find a zip file there.
All right, thank you. I will just look that up.
Yeah. Otherwise, let me know. I'll point you to it again.
So the two last thing that I wanted to say, that this from within the container allows to restart the NRP, so that can be useful when something is buggy and you just want to try and restart. That can be quite useful. Otherwise, there is a possibility to look at the log. That can be useful, and also when things are a bit messy, then we can look at the logs. Here, everything is going good, but sometimes they can be good. And otherwise, if you change the Gazebo roads package with some code, and then you create your own repository, your own plugin, then it's going to be useful also to build it. So that's also a thing that I'm gonna just maybe it's just gonna put this in this text in the chat when I add the useful path. Not sure.
Perfect. Well, thank you so much, Antoine. This has been really useful.
Okay, yeah, but I'm happy that I could help.
Awesome. And yeah, we'll definitely be in touch, and we'll do some awesome things with your NLP.